All right. So what did you all think of the exam? Any comments? Well, I hope that, like I said in my email, I hope you kind of know what's expected from here on out. You got to be doing your homework. All right. If you have any questions over the exam, I did put out the solutions. So if you figure out that there's something that you feel like you deserve more credit for or something like that, you want to talk about it, we can do that. Just come meet with me before class. Other than that, I don't have a whole lot to say about the exam. 64, I believe. 64.7. I don't want to get too much into the exam because I might start getting upset. But there was 13 Fs, or 13 not passing and 12 passing. 16 of the 22 problems were directly homework problems. Didn't change a single thing on them, not even a number, just exactly a homework problem. I've never done that before, and didn't seem to make a difference. So do your homework. I'm just going to say that. Do your homework. Study your homework. We have a lot to cover. Unfortunately, the day I missed was two of the most important but tougher sections in the class. So hopefully you watched the pre-class videos for 2.6 and 2.7, and then I actually included, I believe, 4 different links to the lectures I did. Was there 5? To lectures I did for those sections fall of this past year. So I know that was a lot to have to sit through, but I hope it in some way gave you an idea of what these 2 sections are about. So what I'd like to do now is I'd like to start in 2.6, which was implicit differentiation. I'm going to just go through real quick, talk about what it is, and then we're going to just do problems. We'll do lots of problems today. And I will start with requests. But first, let's look at the section for 2.6. So the basic idea was that anytime we have an equation, which we call an implicit equation, what is the challenge? What makes an implicit equation versus an explicit? Okay, vertical line test might fail, right? And also, explicit equations, you can solve for one of the variables. Implicit, it's hard to solve for one of the variables, like this example here. It would be very hard to isolate y by itself. It would also be hard to isolate x by itself. So you couldn't look at one of the variables as a function of the other. But it makes perfect sense to have tangent lines, right? Like there are tangent lines all over this curve. So we should be able to find the slopes of those tangent lines. And the question was how. So let's start off with an example. Does anyone have a request from 5.6 that they would like me to, 5.6, 2.6, that they would like me to do? Number 15? Okay. Okay, I'm looking at number 15 from, this is 2.6. So it gives you y cosine x equals 1 plus sine xy. And the instructions here are to find dy dx using implicit differentiation. Now, dy dx for us really means what? What has dy dx meant like in the past? Y prime, the derivative of y. That's right. So this is just y prime is what we want. Now, to start off implicit differentiation, what was it that I always did? Yeah, I always do like a little squiggly line just to let you know that's my way of saying I'm about to do implicit differentiation. So on the left side of this equation, I want to differentiate y cosine x. What rule do we have occurring on that left side? A product rule, right? We have y times cosine x. So we have a product occurring between two, you could say two functions, right? So if I wanted to, I could label this y kind of like the f, and this one's like the g. So when I take the derivative, I should be looking at f prime g plus g prime f, right? That's what I should have. So what is the derivative of f? Or what is the derivative of y? Y prime. Why is it not 1? Yeah, because the original problem, when they write dx on the bottom like that, they're saying treat y as if it depends on x. So if you differentiate y with respect to x, you get dy dx, or y prime. So there's two ways you could write this part right here. You could write dy dx, or you could write y prime, and I prefer y prime. The next part of this is to write down what g is. Now what's g? Careful, g, not g prime. Cosine x, and then cosine x. Now we do plus, right? So I'm doing two rows there, right? The first row here is one way of doing it. This is the second way of doing it. Just using different notations. Now g prime. The derivative of cosine of x is just negative sine x, and that's because we are treating x like the independent variable. So we have negative sine x. I'm going to put it in parentheses. That's g prime. And then times f. F was what? Y. Just y. So down here, if I did it this way, negative sine x times y. Okay, any questions on that? Are we done? No. With implicit differentiation, you now have to look at the other side of the equation and do the same thing. Take the derivative on the right. So what's the derivative of 1? 0, because derivative of any constant is 0. So that's going to go away. Now I need to look at the derivative of sine xy. What rule are we going to have to use here? Chain rule. Because we have sine of something, right? Sine of some junk, good. But the junk is going to require what rule? Product. Right? Okay, so let's see how this works out. What is the derivative of sine of some junk? Cosine of the junk, right? Then chain rule says times the derivative of the junk. But the junk is a product rule, right? An f and a g. So I'm going to say times, over here I'll do it in red, times, it's going to be f prime g plus g prime f. What's the derivative of f this time? 1. What's the derivative of x? It's 1, because we're differentiating with respect to x. So we get a 1 times g, y, plus g prime, which is derivative of y, which is y prime, times f, which was x. What do you think the most common mistake I see for that part in red on the right side? What do you think the most common wrong answer I get is? I usually get 1 times y prime inside there instead. And that's differentiating each one, but not applying the product rule, right? You can't do that. Okay, now if I'm sticking with the notation on the bottom, it would have been this. Y plus dy dx times x. Oh wait, I flipped them. I'm sorry. Did y'all notice? Did y'all notice that? Oops. The first one is the one where I had dy dx. The second one's the one where I had y prime. I got these backwards. This one down here should have been the y prime. Okay, now I like this one. But you should all understand that y prime is really just the dy dx, all right? That's going to help in the next section. Okay, so once you get to this point, what do you have to do? Try and get what? Y prime by itself, right? So let me take one line just to clean things up. I'm going to get rid of all my little dots, like y prime cosine x. This is going to become minus y sine x, just moving the y out in front. On the right side, I get cosine of xy times, in parentheses, y plus y prime x. So I'm trying now, the goal here is to get all y primes alone, together on one side. Everything that doesn't have a y prime on the right side. Y'all remember me saying that at some point in my videos? Can I move the y prime on the right side to the left side right now? What do we have to do first before I can get that y prime x from the right side? Expand. So I have to multiply cosine xy, it's like a factor, through this parentheses, right? That. So I'm going to get y prime cosine x minus y sine x equals y cosine xy plus y prime x cosine xy. So anytime I multiplied the cosine xy by something, I put that something out in front of it. That okay? Questions? All right, now I'm going to take the terms that have y prime in them and get them all on one side. And I'm just going to move them to the left. So to move the one on the right to the left, I subtract it, don't I? So I have y prime cosine x minus y prime x cosine xy equals y cosine xy, then what? Good. Plus y sine x. So what did I do there? I mean, I moved the one on the right to the left, but I also did what? Moved that thing that didn't have the y prime over to the right side, and it came over here like this. Now, why is it that I did that? Why am I trying to do this? So I can factor the y prime out now. So this is just all algebra, right? Y prime comes out. I'm left with cosine x minus x cosine xy equals y cosine xy plus y sine x. Jeez. And final step, divide by everything on the left side that doesn't have y prime. So y prime equals y cosine xy plus y sine x all over cosine x minus x cosine xy. And this is the answer. Did that help? Yes? So on a test, the first thing I'm going to look for is do you have that line underline, or the line in yellow there, right? Do you have that? Okay? If the problem's worth 10 points, that's 5 or 6 points, just getting the derivative correct. And then the algebraic manipulation is the rest of the credit. All right? So I look for that first, and then from there, see how you do with the algebra. Okay, before I move on to the next problem, I'd like to illustrate, again, because it's important that we understand what the hell it is we're doing. I'm going to type in this equation in, I can't do it this way. I've shown you this program before to plot stuff. You can actually put in an implicit equation. So it's going to look a little weird when I type this in. Y times cosine XX equals 1 plus sine